morning, everyone. I'm going to present my cantilever project to you today. So, the idea is, what is a cantilever? A cantilever is a projecting structure that is fixed at one point and then loading, carry load at the other. So this is basically like a cantilever, this part, and then we need a span to necessarily hold the cantilever in place. And then for this assignment specifically, we need the cantilever to be 3 feet and the span to be 2 feet. So it always starts from body position to figure out how the cantilever works. But there's always a limit to the body, so that's why, like in this photo, we have a big span and a little cantilever right here. But it doesn't matter, we're just going to study the details of the structure and then see how specific details works. So in the next slide, we study detailed drawings, like back to back, knees to knees, and for this one, hand holding ankle. And to study this, we can see that the hands are in tension. So later we can replace a hand by a tension member. And then we start to draw diagrams to study. Now we didn't take pictures for the plan wheel, so I just made it up in Illustrator. It's just all circles. But the idea is to get like which part is wider and which part is narrower, so we can later integrate into the cantilever. And then this diagram shows how it moves in time vertically, horizontally and vertically. And the next slide is the elevation. Like see the hands, how it moves from the top to bottom, and also it moves horizontally and vertically. And then this is the force diagram. By drawing this, we can see that all the top parts are in tension, but the legs and the hands, and also the part that carrying load is in compression. So this is really the first project we're starting to use tension members, because the first project, the tower, is all compression. And we were told by our professor that the tension member for suspension is not allowed. So what is a suspension? Now in this picture, this is Brooklyn Bridge. This wires that's holding the bridge is in suspension. Now if we cut the bridge in half, this part becomes a cantilever. And this part is holding by the wire to the top of the power. And this is called suspension, which we're not allowed to use in our cantilever. So what we can do with the wire, with the tension members. And then we're introduced to the truss system. And among all the truss, we use only Pratt for all of our cantilevers, because Pratt is the simplest one, and it's also very sufficient. So we start to build our first cantilever. And in the first one, it's really basically just study the structure instead of the design. See, all the cantilevers are really boxy, it's all squares. And also, the advantage of this cantilever is that we made individual squares and then combine them together. So there's our structural duplication right here. And also, like, it's a little bit crooked. And another thing is that in this cantilever, we actually use the Pratt truss in the wrong way. So the truss, it doesn't work in this one. But it does hold a water bottle right here. And also we went on to build a second model. So then we incorporate our body more into the cantilever. We find out that we have a lot of V shape in our body. So we build like this. And then also a cantilever that is a united whole. And the problem of this one is that the cantilever is not integrated into the body, into the span, which all the loads carrying all the forces going down, and there's nothing support right here, so this is really a weak point. So when I push much, this part will eventually crash. And also, according to our body, the shoulder and the waist are wider, but right here it's narrow. So we made the whole cantilever taper to the end, and then there is our two hands right here, and then narrower right here, wider right here, narrower right here, and then wider again. So as to this point, we're using piano wire as the tension members, but we're introduced to fusion wire. What's the difference between piano wire and fusion wire? The thing is, piano wire is really rigid, and the fusion wire is flexible. So you can take the fusion wire, and then we'll pull two sides. It will extend. The good thing about fusion wire is that it's really easy to get in tension. We'll fix at one point and pull the other and fix the other point. It will be in tension, but the piano wire, if you fix at one point, the other point is still not really like in tension, so it does not work as well as fusion wire. So then we went back to our body diagram, and then just basically draw sketches by connecting the important joints, just made up some structures. And then we made our third model. This one, we really incorporate the cantilever into the structure. They are now like independent now. And then we took off the top part because the top part is all in tension, so there's no point of using basswood as a tension member. We can just replace it by the wire. And then we use pad trust and then cross bracing inside, and it does work really well. And we continue to build the fourth one. This is our final. I have more documentation because the final archive. So we can see in the plan view that it's shorter at the end and gets wider, and then to the end it shorts again and then get wider again. And then these are the perspective view of the cantilever. And it's really kind of chunky, but all the things are functional. So if you see the tension wire, if you put a load right here, all the tension wire is continued to the end. So we'll pull everything to the front. And then this is the detailed drawings we made. And see, this is lots of wires right here. And not only we have the tension on top, pad truss right here, we have added cross bracing to allow more weight loading. And this is a force diagram. The top part is all in tension, and the bottom part is all in compression. And then we tested with a load. 2 ounce, 4 ounce, 1 pound, and 1 pound and 4 ounce. It does hold a lot, but the thing is, because the wires are extending, so when I put much load, it doesn't crack anywhere, but it will eventually touch the ground. So there's a limit to this structure. And then we'll superimpose it, see how it moves like this. And then this is the ground, they touch the ground. Thank you. Any